If you want guaranteed full marks on your physics board exam, electricity numericals are where you get them. You only need to master one core rule. But to use that rule, we first have to look at where it operates, a standard electric circuit. This schematic shows the 4 basic components you will see in almost every problem. First is current, represented by the letter I. Think of this as the physical flow of charges through the wire, exactly like water flowing through a pipe. We measure this flow with an ammeter. Second is potential difference, or voltage, marked with a V. If current is the water, voltage is the pump. It is the push provided by the battery that forces those charges to move through the circuit. Third is resistance, or R. This is the opposition to that flow. It acts like a narrow section in our water pipe, or the filament in a glowing light bulb, slowing the electrons down. Every circuit problem you face will simply ask you to calculate how these 3 elements, the flow, the push, and the opposition, interact with each other. That interaction is defined by Ohm's law. It states that the voltage and current are directly proportional. If you increase the push from the battery, the flow of current increases right along with it. To make this a balanced equation, we introduce R, the resistance, as the constant of proportionality. This gives us our golden rule, V equals I times R. During an exam, under pressure, algebra mistakes happen. To prevent that, use the formula triangle. Draw a triangle, put V at the top, and I and R at the bottom. Here is how it works. If a question asks you to find voltage, cover up the V with your finger. You are left with I next to R, meaning you multiply them. V equals I times R. Need to find current? Cover the I. Now you see V over R, so it is voltage divided by resistance. Cover the R and you get V divided by I. Committing this single triangle to memory ensures you will never use the wrong formula variant on a test again. Examiners often test Ohm's law visually using a VI graph. This chart displays 4 different metallic wires at a constant temperature. Notice the perfectly straight lines starting from 0. That linearity is visual proof these conductors obey Ohm's law. Current goes up predictably. Here's a common trap. Assuming changing voltage changes the wire's resistance. It doesn't. Resistance is a fixed property determined by length, thickness, and material. The slope of each line represents a specific fixed resistance. Line P is a completely different wire than line S. In any standard word problem, unless the text specifically says the physical wire was cut or replaced, you can rely on the resistance remaining completely fixed. Knowing the math is only half the task. CBSE awards stepwise marks, so we need to structure our answers using a 4-step matrix: given, formula, substitution, and result, with unit. Let's apply this. An electric iron of resistance 20 ohms draws a current of 5 amps. Find the voltage. Step 1. Extract the given data. R equals 20 ohms, I equals 5 amps. Step 2. Write the formula. V equals I times R. Step 3. Substitute the values, so 5 times 20. Step 4. Write the final result, 100, and append the unit, capital V for volts. Let's look at another one. A 12-volt battery is connected to a 24-ohm resistor. Find the current. We pull our givens. V is 12, R is 24. We write the formula, I equals V over R. We substitute 12 divided by 24, giving us 0.5. We finish by writing the unit for current, capital A for amperes. Sticking to this 4-step matrix ensures that even with a small calculation error, you still secure the majority of partial credit for your setup. Now it is your turn. Find the resistance of a toy car motor operating at 6 volts and drawing 0.2 amps. Pause the video and write it out using the 4-step format. Let's check your work. You should have written R equals V divided by I, substituted 6 over 0.2, and calculated a final result of 30 ohms. If you got that, excellent. But stay vigilant. Examiners regularly deduct marks for 3 specific things: forgetting to convert units like milliamps to amps before calculating, skipping the written formula step entirely, or leaving a naked number without its final unit. Consistent formatting and double-checking your units is the best defense against these entirely preventable mistakes. To lock this in, here is a consolidated master sheet of everything we just covered. Grab a screenshot of this frame right now. Keep it on your phone and review it before you walk into your physics exam. Solving these numericals doesn't require complex math. Just remember your triangle, follow the 4 steps, and carefully check your units. You are going to do great.